Hi, it's Gadget UK here again. A bit chilly in here today, hence the heater noise. Yeah, this is a high-tech keyboard. This has come from Right Retro Gaming, Anthony. It looks nice, doesn't it? I like this. Are these replica? They kind of look new. I don't know. They look really nice though. I think these are replica, like new keys. This is one of the chicken lips keyboards. So you can see, it's an actual PCB, no membrane, which makes these really desirable. But maybe not this one. Anthony sent me this because a message has been going to and from, and he's been having lots of trouble with this. I think he swapped out the IC, the main IC there. We'll get this plastic cover off in a minute. There's lots of repair work going on here. You can see there's like the odd wire in various places. Here's one there as well. So yeah, he's been struggling to get this working. I can't honestly remember what the latest state of play with this is, but I think you plug it in and it just doesn't work. I think maybe the caps lock comes on, I don't know. This would originally shipped with the really early boards like Rev 3s, and I wasn't aware of the difference, but Lift 2 kind of looked at the schematics for me. We were trying to help Anthony, and I asked on Discord, isn't anyone aware of the difference between these high-tech keyboards? Because I've never actually worked on a high-tech one, I don't think. I may have worked on one in the past and cleaned the contact up, but that's 30 years ago. I don't think I've seen one ever since. They're so rare. And Lift 2 pointed out, I think the clock and data were flipped on the Rev 3 boards. Now, I'm not so sure how accurate that is, or whether there was a mod done to the PCB somewhere, either on the keyboard or on the actual motherboard, because I'm pretty sure I tested my Rev 3 using later keyboards and everything just worked. So I don't know, I honestly don't know, but what I do know is that's socketed up. Anthony swapped the main chips, he's recapped this. We've got some, like I say, sort of 4 or 5 different traces that are damaged but have been patched. Solder points here, yeah, they just need a bit more flux, don't they, in places. There's 2 caps here that, well, it's almost shorted, that cap, as it's got folded over. Could have happened in transit. But I don't think that's going to be the issue. I think I'm going to start by, let's see if we can work out to get this off. It's going to be that screw there, isn't it? Yeah, we'll get this plastic cover off here. I'm not going to connect it up and try it. Absolutely not, until I've worked out what's going on with the power and ground rails. And, why is that? There you go, it's on the underside, that washer, isn't it? And just a sanity check to make sure there are no shorts, everything's wired up correctly, etc. So yeah, focusing on this here. So, you can see we've got a little bridge there. I need to make sure that's joined and it's not short to that pin. We've got a bridge there, it's where the traces have lifted. And then slightly further over here, we've got a wire that comes down here. We've got a wire somewhere up here, I think one there maybe. So there's a few broken traces. I will measure around and stuff, clean up here. Yeah, we've got a little scratch there, but it's just a scratch, I think. Anyway, I'll report back in a minute. So, apologies about wobble count. So, starting up here, that is the far pin on that chip. Yeah, the large dip chip there. And if you look at its connection, it's joined to this cap that's through here. I need to check the other side to see if there's a wire on the other side that goes somewhere. The point being here, I'm not sure whether that's going anywhere, actually. It's like it might be the ground on the chip, it's joined to the ground on the cap, and neither of them are going anywhere. So, it might even supposed to join here, I don't know. So I need to just check what some of these connections are. Anyway, that's that. So straight away I'm thinking this here could be a problem. And then we've got, pads and things fixed here and here. That doesn't look like that's very well joined onto that. It's too thick gauge wire, that, and maybe a pad replacement might be an idea for that. I don't know. And then we've got a thick wire here. Yeah, and there's another bodge there. I don't like that. It's too close to this trace here. Inductive coupling and stuff you get with things like that. That needs certainly moving away from this main rail. Anyway, all I'm going to do is literally remove some of these things, replace the wires with a more suitable, tidier wire maybe, certainly that one, and then do a bit of measuring around here. I'd like to understand what pin is that on this chip. Is it a ground? And if it is a ground, test it to the 7.4 series, which are located over here. So hopefully this is going to be nice and easy. So the first thing, you can see this cap here is a bit close to that. There's not a short, oh there is a short, there's a short there. So let's just move this cap away from there. Those may be intentionally joined, yeah they are intentionally joined. In any case, I want to move that away from there. The next thing is this cap here and some of these ceramics, you can see that blob of solder there? It looks awful. It needs a bit of flux. It needs some braid to remove that solder. We just need to just work out what's going on with the pads. But if you look at the extended greeny surface area here, this is going to all be ground. Yeah, it's very common to have large areas of the PCB like this with ground. So when you look at, say, the negative side of this cap down here, if we measure from that negative side to this cap down here, which looks like it goes to the larger area, yeah, they're joined. So I would expect that. That's the ground. And then when we come over here to these 7.4 series, so we've got, that's a 7.4, so it's grounds down here, that's a 7.4, it's grounds there. So the grounds on those two chips are joined, yeah? But the ground to this cap here is not joined. Onto this cap down here is not joined. And it's not joined to there. So we've got a break in ground somewhere on here, which probably means like this has probably not got a ground, or it could have died from latch up or some of the failure, a similar sort of failure. As a result of that, you know, sometimes these can get powered parasitically by their I/O pins and things like that, and damage can occur. You may not think it can, but it can. So the first thing is, like I say, is trying to understand this ground issue, and the way I'm going to do that is by getting some flux onto each of these points where these caps are here, and just make sure, because what can happen, you see, it looks like lots of pads have been lost when these have been pulled off, and if you lose a ground point, or a point that's joining two separate areas of ground that happen to go through the pad that's in the middle there, and that pad's gone, you get a break in ground, and that, I suspect, is going to be part of the problem with this. Now there may be schematics for this, I don't know, I've never seen any. But anyway, we're going to start with that one there, I think, which is going to get a little bit of flux there. We'll do this one down here, a little bit of flux there. So we may end up adding a little bit more solder to replace what we're about to remove here. But in the first instance, all I'm going to do is use the braid and just mop up a little bit, you know, get rid of that big blob there, and then just see if we can inspect a little bit. Right, we're at temperature. You could argue remove the PCB from the thing, but I don't think we need to here. Yeah, I'm just gonna, there we go, mop all that up. And then just inspect. Yeah, so that is a ground, there's nothing wrong with the pads there at all. It was just some horrible solder. So yeah, I'm just gonna add some fresh solder here. I've got flux around it already. Well, we're just trying, you can see already that's flowed a lot better. Let's try and get in at a shallow angle here. Let's give it a few seconds to heat. There we go. We've got a nice shiny solder point there. It's not beady and sticky uppy. Pad's alright. So I'll just clean around that and I'll move on to the next one. And I'll just repeat this around here. There's a few of those. There's one down here that's like that as well, I think. All we're doing at this stage really is clean up and inspection. Let's just have a look at that. Yeah, there's perhaps a little bit of solder, just needs removing from the wider part of that. Yeah, it doesn't look so clever. They're kind of like a star thing. It's like you've got the pad like that, and then you've got like a little bit here, a little bit here, you know, a little bit that sort of sticks out here, and a little bit that sticks out there. So as a result, when you solder on it, you get like little lumps around the sides and things. It's a bit odd, but anyway, that does look a lot better than it was. See, like as I move that there, there's a big lump of solder sticking up that is not joined to the actual pin, if you see what I'm trying to say. It's like it's not soldered on this side. And when you get that kind of thing going on, it could mean that the top side isn't joined to the bottom side at that point. Alright, so I'm trying my best here because I need to avoid the keys. Hang on. Successfully creating some awful shapes in the solder here. It looks worse than it did before. When I first flowed that a second ago, it was alright, and then it's... And you know what? The temptation might be to blame Anthony here for crap soldering. He's not done crap soldering at all. It's the shape, as I say, that little plus sort of shape that's around each pad. It means the solder goes weird bleeding orientations around. Yeah, so the other one we got some flux on was that one down there. I'm just going to refloat that. That's it. It'd be so funny if we measured the ground now, found it and showed it back up again. I don't think so. I think it's going to be a break or something somewhere. Hang on, we got a ground now. Was it really that simple? It can't be that simple. Yeah, look, everything's joined back up. So all we've done is reflow 3 ground points. I don't know how. Maybe it was this one, because it looked like the cap was not actually on the ground, which means that the trace that goes to that cap there through the other side would not be joined to this side, and that's all you need. That's all you need is one missing ground connection, and yeah, things aren't going to work. Yeah, on that side everything else is looking alright. So you know what, I'm just going to flip it over, and I'm just going to inspect around here, just see if anything else needs immediate attention before I test this. But then I'm just going to check connections, you know, ground, VCC. If 5 volts and ground are going to the right place, I may then just give it a try. Right, so I'll just summarise what I've done. Obviously I've replaced or extended that wire there, all the way to there, and tidied up its solder point. Replaced the wire here. It's slightly curled, but it's wrapped around the pin and it's joined up there carefully. This is a leg from a cap or resistor or something on the other side, so yeah, that's okay. I've just straightened out though, reflowed it on both sides. Trimmed off any of these little excess bits here. I'll show you, like these components here, where the legs are extended right over and potentially touching the connection there. And there's a few of those, 4 or 5 of those, where I just trimmed the ends off. Same here, trimmed the end off that was sticking out, trimmed the end off that was inductively coupled to a trace there. Same over this side. So everything looks alright there now, but I also scratched in between it. There was a few pins where I'm like, is there a join there between those? And I just scratched, and there's like a particle solder between them. And there was 3 of those, 3 particles I found between things, including over here on this. So even though it's been cleaned, it's not had the gadget clean. So what I mean is, like, you know what I do with a toothbrush and everything, and the dry brush, and give it a really good scrub. There may still be a broken connection or something here, I don't know, but anyway, we'll test the ground and VCC out and then see what it does, actually power it on and give it a try. I did reflow 2 of the pins that were joined together, just to, well, I got rid of the solder actually. I was like, are they supposed to be joined together? So I removed the solder on the 2 pins there, and then yeah, they are supposed to be joined together, but the point is, those 2 pins look a lot better because they've been reflowed with a lot less solder. Just hold it off the table a little bit and just do a wee bit of that. So a quick test of this, it's doing exactly what Anthony described, which is the red caps lock LED just stays on to do anything. I've tried the other chip as well. Now, this is something I've just spotted. I actually think this 555 timer's on upside down, because if you look at the silhouette there, you can see a square edge. Yeah, there's no pin 1 marking. If you look at the 74 series, we've got a little curl there on this one, a little curl there on this, the big dip one, a little curl on the right side. So the fact that that's like that, I think that 555 is on upside down, and I think this is why the caps lock's on, because it's not getting a reset. Yeah, we could probably prove that by grounding just for a short period of time the reset pin. As long as it goes high, then it may just come out of reset. That might solve it, that would prove it. But I think that 555 has got to come off because, well, it's on upside down. And the super annoying thing with this is it's where these 2 damaged wires are, look. Both on the 555. I suspect that what happened was the chip maybe had an issue. At some point he swapped some caps and things, recapped it, and lost to ground, and then when it's lost to ground it's gone, oh my god, what's wrong, start to swap everything, and created some more damage here around the 555. So anyway, let's just try and pull this wire away as I heat that point there we go, that's that one done. And this one here, hang on, this one's going to be a bit of a pain actually. I think I can remove my wire, there we go, remove my wire. You need a lot less temperature than you might think you need. And I'm not sure they have the same through hole stuff going on. What I mean is, like, you know, on a good quality board you'll have a through hole on each one of these dip wires. It goes all the way through, and I'm not sure these have that. It's like two separate layers, and if you don't get the solder on both sides, you don't get a joint on both sides. I could be wrong. That's it, I think. So I'm going to install a socket here. Yeah, so you can see the 555 up here. Let's just grab it and pull it off. Now, to be fair, it's not absolutely clear that that's the wrong way around, because on the left hand side of that there is no sort of white semicircle bit, but the fact it's square here, that's got to be the wrong way around. Anyway, if we socket it, we can't, you know, we're not going to perma stick it the wrong way around, are we? Woohoo! I get to use one of my 8-pin sockets. I've got millions of these. This sort of thing never gets used apart from 555 seemingly. The last time we used one of these was on a 555 on the C16 repair series, and part 3, wasn't it? So if anything, I'm very grateful for Anthony balking this board in order that I can use one of my sockets. Right, there we go, let's stick that on. Now I know what you're thinking, maybe I shouldn't be putting a socket here, because those line up with the case, don't they? A bit of, mind you, that's not really much higher than this cap. I think it'll be alright. You know what, I'm not going to worry about it. If it sticks up too high, Anthony will have to remove the socket and just solder it straight on the board. So let's have a quick clean around that. Alright, 555 timer the other way up. So connect power, switch it on. I'm just going to put my finger on there. Yeah, it's working now. Haha, that's what it was around the wrong way. You can see this here. Watch, when it gets a reset, watch, caps lock, on, off. And then you press it and it works. It's amazing what happens when you get chips around the right way. So that's all it was. I mean, I say that's all it was. There were two things, weren't there? There was a missing ground. That would have caused someone to go off on a tangent trying to replace things to work out what might have failed, but it's Occam's razor again, isn't it? The simplest explanation being the most likely. In other words, what did you do? Oh, I replaced a few caps. Yeah, it's going to be one of those points on the caps. That's what it is. You can think, oh, caps, how can caps cause it to not work? But when you've got a missing power rail because of a damage from a cap point, yeah, of course things aren't going to work. So yeah, and that's the thing, capacitors, most of these, apart from one for the reset here, which is that one, probably the small one, these are the ones are on the main supply rails. So just by virtue of damaging a supply rail by trying to recap something, you can create secondary faults. I mean, you know, he could have been unlucky, that could have died as a result of that. One of these could have died as a result of not having a ground. So this is the thing, people go, oh, recap, you know, protecting this thing moving forward. Yes and no. You know, yes, in the sense that the capacitors won't be the thing that kills your system over time, maybe if you've recapped it, but just by virtue of creating a problem while you recap it, you end up killing it. So we are testing on the A2000 here. Let's try and get command line up, shell, so I'll do Q, hang on, not work. So this would have just died. Now this might be the keyboard MCU that's playing up now, so let's just try. Oh, it's died. Yeah, there is a problem with this keyboard, and it may be the MCU. We've got another problem because look, it's just doing random stuff. But maybe that's the clock and data line round the wrong way. So let me try swapping that around, I think. Yeah, so I can see Anthony has swapped these around because at some point, because they're a little bit mangled there, just a tiny bit. So I'm not sure which way round those would have been from factory. I think black is always on the end. But anyway, car now swapped around. So we need ground to green. On my adapter here for the 2000, the black line is the ground. Sorry, the green line is the ground. So that's joined up there. Let me try that, see if that's any better. Just watching the keyboard here. No, it's still not working. Look, now it's working. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so I think what I need to do with those two connections is just tighten them up a little bit. So I'll pull them back out, I'll try and tighten them slightly, and you know, bend the little springs upwards so that they hold in place. 4's not working, look. After all this, 4, 5, 6, hang on, it stopped working again. Now it could be the keyboard MCU actually, and it could be these connections here flaking out. I don't think it is though, because it stops responding. So this was his original fault, I think. And bear in mind, I did swap back to the other chip, so you know what? It probably was all about the keyboard MCU all along, and then the other stuff's just happened as a result of, you know, trying to repair it really and trying to recap it. That's it, just inspect, make sure they're all in. Switch the 2000 back on again, just put a finger on there. Yeah, caps lock went on and then off. So we'll give that another try with the other chip. So it looks like maybe the keyboard MCU was the fault, but there could still be another problem on here. Like maybe that 555 took offence and is now occasionally resetting it. But if it was resetting it, the keyboard would start working again. So it can't be that. It could be one of these maybe. And I think one of these is for the reset actually. So maybe even both of them. So you know what? I reckon that should work now. And just testing the caps lock here as it's booting, just to make sure it hasn't had a reset, you know, like midway, and it's still working. So I'll report back when I've tested this a little bit. I'll let Anthony know that it's going to be pretty expensive to repair. There's probably 2, maybe 3 donuts. Right, intermittently working, and I thought maybe it's a clock thing. That crystal on the other side feels really loose. So I reflowed this pin. Pins reflowed nice and fine. This pin here, oh hang on a minute, where's the pin moving around? It's come off the oscillator. This is, I think, his issue. Where's my solder pump gone now? Yeah, it's often, like I say, Occam's razor again. Simplest explanation being the most likely. So I think we need to take this off and just have a look at it, because one pin is, well, not there really, is it? That one's gone. That one's gone. I don't know, has it fallen through? I don't know what's happened there. Or has it just got no legs? It's fallen off, look, it's here. Up. Now it's fallen on the floor. Oh joy. I'll try to find that now. I mean maybe this isn't the problem, because it still has legs. But you know what, those legs are pretty sturdy that's left of them. So I actually think it had broken off on one leg. You know, they would have been longer than this originally. Yeah, that's what I think. I think this might be the issue. The other possibility here is both of these MCUs have got the same fault, because that is a common fault with them, where they just suddenly become intermittent. Because I've got one like that. So it wouldn't surprise me if that was the issue. But we did have those other issues, like a missing ground, 555 around the wrong way, etc. So it's not like there was no problem with this. There's a few problems with this. It really was wobbling all over the place, like really easy. You just had to touch it and it moved. So I actually think that might be it. Let me just touch that now. Yeah, that's really stiff now. Yeah, I think that was the issue. I think it had an intermittent clock. I think its clock was just like wobbling all over the place. So let me boot that up again and we'll try and test it again. Hang on a minute, now it's not working at all. What is going on? So there's me thinking I fixed it. Look, caps lock is not coming on, and it is plugged in. I've tried unplugging it and plugging it. I've messed around with all the connectivity. I even tried the other chip, and it's doing, when I say the other chip, the other 6570, it's doing exactly the same with both of them. It just doesn't work now. Maybe the pads are bad there. Let me just test those pads. Or maybe the component is actually faulty. It's strange, isn't it, how we've just resoldered it and now it's not working at all. Yeah, that's joined. And that's joined. So, how can that be? Yeah, it's not working. Let me just try moving it, crystal. Hang on, now it's working. No, it's not. Alright, it's intermittent, let me show you. Yeah, so hopefully you can see caps lock not working, and I'll just, hang on, try and touch that crystal. Just moving it around a little bit. I'm sure it is that. I'm going to scope it. Scoping the crystal outputs here, I'll show you on the scope. So, as you can see, we've got a clock, so it is oscillating, despite the fact that I was just faffing around with that crystal a minute ago. And it did start working just for a split second, and then it froze again. And that was me just like touching around the crystal, moving the crystal a little bit actually, just pushing it over one way or the other. Frequency 2.994 megahertz. So, I don't know, it's a little bit weird. So reading Anthony's original message there, you can see that it pretty much swapped everything, and apparently it just stops working. Well, that's what I'm seeing here, so I think the original fault is back. Yeah, so this is making no sense at all. The chips are all good. I did actually test those MCUs on another keyboard. The PCB is good. We've got ground and VCC connections. I scoped the crystal. It can't be the crystal. We swapped the crystal. So the conclusion, it's haunted. It has to be. Right, an hour later, I have finally worked out the final issue with this haunted keyboard, seriously. So yeah, it did relate to this clock, the crystal. Yeah, the crystal was a bit loose, but then obviously we swapped it out. And at that point, it just was barely working at all, yeah? So I was like, well, what the difference? I scoped it. I'll show you that. It's 3 megahertz. There's nothing actually wrong with the crystal, but that's a clue. So I'll just leave you for a few seconds. Think early version. What do you think might be the issue in terms of the crystal? Yeah, and look, it's working now. I'll show you in a minute. But this is the first time in an hour it's been working. I tried a lot of different things, measured a lot of things, pressed around, moved things, pressure, wiggled the cable. Nothing made any difference. And then I came up with an idea and I was like, I bet that's it. And I did it, and it insta-worked, straight away, instantly. So that is the issue. Yeah, and if you haven't worked it out, I've just bodged on 2 caps here, across the crystal pins. The later boards have that, but this board doesn't, which means that potentially it's not got the right loading on that crystal. How it would ever work, I don't know. The reason I've wondered about this, and what made me go look at that, I'm thinking maybe this has got a later revision, because Anthony did say something about this had an earlier version chip, and on the earlier version chip the oscillation was probably done differently. Maybe it had some capacitance already in there for the clock pins. I don't know, but I think that's the issue. And it works every time now, so I need to test this for another hour or two, do some cold starts on this. So I'm not going to send it straight back to Anthony tomorrow, as I had sort of thought about. But that is the issue. And the other behaviour with this, by the way, when that happens, when the LED doesn't even light, it does nothing, the system doesn't boot. So it's like puts out spurious signals, maybe it's stuck in reset, something weird happens, whereby the Amiga will not boot when the keyboard's in that state. So, yeah, very interesting. I really like this keyboard. I want to get one of these high-tech keyboards. Right, so here we are, a few hours later, just cold tested it, I saw the caps lock flash, and it's working. Yeah, I say flash, it came on and it went off. I think that's normal, as it gets its reset. So yeah, it is the issue that it just needs those capacitors properly installed, and so I'll do that next. And if you're wondering what the issue is, it's about the way that those, let me just get it, I forgot the old one, or I've done with it now. Yeah, this, we use the term crystal, but you know what, it's actually a resonator. It's not an oscillator. So a crystal oscillator, you know, they're usually 4 pins, it's usually like a 14 pin package, one of those rectangular crystals there, and that has power and ground, and it's probably got the capacitors and things, and maybe even a transistor or something in there as well. An inverter, that is. And the way crystals work is you've obviously got your thin slice of crystal inside a package like this, yeah, but in order to make that oscillate, you have to, I think you have to use like an inverter or something to produce like this signal, yeah, but then ultimately you need capacitor on each side, and it's to do with phase shifting. I think it phase shifts by 180 degrees. When it starts up, I think that an easy way to think about these things, and this is my vague recollection, is a crystal can be seen like an inductor at just above its resonant frequency. So if you think of it as an inductor and a capacitor and capacitor, you've got an LC circuit. And LC circuits obviously give you oscillation. And it's about getting that 180 degree phase shift as the inverter, you know, your inverse signal, it's like a charge pump, I guess, starts the process off, and you have a feedback to the other side of the crystal, so it kind of starts itself up, oscillating naturally by the resonant frequency in the two capacitors, you know, an LC circuit effectively. And because of the way the crystal's tuned, even though you get that kind of like excited oscillation that starts up, it naturally stops at its frequency, its exact frequency, so you don't get like harmonics, or it doesn't go beyond or below its frequency. It's kind of like a self-perpetuating thing by the fact that you've got, you know, some voltage, some inversion to get going, the 180 degree phase shift, which ultimately, by the time it's fully started oscillating, I think it's at 360 degree, and then it just oscillates, it works. I probably just made a load of mistakes explaining that's just based on what I remember, but you know, the way I was told is about loading. If you load something like this down with about 20 odd picofarads on each side, it's usually enough to get it going, and that's exactly what we've done here. Yeah, with the 22 picofarad caps, it works. Now, looking back at the board that I borrowed that resonator off, there are 2 caps here, yeah, and that was the point where when I spotted those, I was like, that's going to be the issue. And then I went and fitted some on there, but I fitted 22s. It's working with 22s. I'm going to go with 22s. Yeah, so anyway, I'll just fit that resonator back on this board. There's no point in swapping them around. They're exactly the same, 3 megahertz, because that runs at 3 megahertz, and that's what the issue is. So, how did it work originally? Well, it would have had a different chip. I think this is like the 6570-036, is it? That one's the same. The other spare's got the same. The one of mine here, I've just dropped that balloon resonator on the floor. Yeah, mine, this one's intermittent, is the same as well. So, it's all going to be about a prior revision, I suspect. I think the early board that he's got here, this early keyboard, would have had an early revision. It may have had a different oscillation circuit. It may have had, you know, some caps or something within there. It didn't need the caps, whatever reason, I don't know. But that is the issue. That's it. So this haunted keyboard is finally fixed. And you can see that there, yeah? And it was super sulky before. The best I had it working was about 2 minutes when I thought I'd fixed it, and then it just suddenly stopped, and I'm like, what's going on? And I power cycled it, the light wouldn't come on again. And that was where I went looking at Anthony's original email, and that's what he was describing it as doing. And I'm like, hang on a minute, how did we get to this point? I fixed some traces, we changed the 555 round the right way, you know, it was all good and working, and then why did it just suddenly stop working? So yeah, it was haunted, haunted at that point. It was just not oscillating properly. And you can wonder why. Why would it oscillate for a period of time? And then Anthony was pointing out you could switch it off, leave it overnight, come back the following day, work again. Maybe for 10 minutes or so, and then stop working and not work again until the following day. So yeah, and it's all about impedance and temperature. All of those things obviously have an effect. And capacitance, that's the other thing, you know, capacitance. These things change. When something's been running for 5-10 minutes, it's warm, those things change, yeah? So the very, you know, the characteristics, the way that this is going to behave and the way the oscillation circuit in there is behaving changes over a period of time. You stick some capacitors in there, you've now got a constant. You've now got a constant in terms of it being able to get the correct phase adjustment there and get that, the exact frequency kind of locked in. if you see what I'm trying to say. It'll just, you know, naturally resonate to, in this case, 3 megahertz, and there's going to be temperature and humidity and all these things just might make slight variations. Is not a problem. But when you've not got the control of that, and that clock could be going all over the place to a degree, probably. And I scoped it was 3 megahertz, but there was probably some like jitter or something going on with it. And when you get things like that, it can be, you know, in terms of a clock pulse detected on here, if it's strong enough. This is the other thing. When you get the feedback loop there, where it can resonate, you know, oscillate its exact frequency, you know, resonate. I'm trying to think what the term is. When it can oscillate its exact specific frequency, and it's kind of like self-perpetuating and locks into that frequency via the inversion and you get amplification, that in that feedback loop of the oscillation there, you get a stronger signal. And that's the thing. So you've got a weaker signal without the caps, and you've got more chance of things like, you know, temperature and humidity having a huge difference to whether that clock is doing exactly what it should be doing at exactly the right frequency. So yeah, a lot of waffle aside, if you know more about that and you can explain that better than me, please post in the comments down below. Please don't be critical. I'm not an expert on crystals. Crystals is always my the area that I lack on, I guess. You know, there's stuff with resonant frequencies and things like that. It's all, you know, stuff that I remember. I studied it, and well, I don't remember. Some of it I don't remember. Right, so the way I am going to do this, I've got 2 pieces of red heat shrink here. We'll heat shrink these, but we're not going to leave them protruding like that at all. It's just to test it, really. So yeah, we'll pull off that one there, and I can't even see what I'm doing here. Let me just bring the magnifier in. Yeah, using the magnifier from my parents here from Christmas is long since gone. I did scratch that little crack there as well as a scratch. You know, use the fiberglass pen, so we'll get a little bit of solder onto that, I think. The funny thing with this, thinking about this, and I haven't found any evidence of this online. Yeah, so what I mean is, you search online, see if you can find anybody who's done this. I can't find anybody. I can't find any reference to this being a known issue, this being the solution. There's no way Anthony, I think, would have worked it out, and I think most people, and I'm not being big-headed, I just had a stroke of genius thought. And the reason being is, once I saw the behaviour, the problem come back, and I'm like, oh my god, this is haunted. Yeah, you start to run through the motions and you think, well, what could it be? And there's nothing it could be. Anthony took the hard work out of this by swapping all the chips. So I'm like, well, there's no way. And I did actually swap the 555 just because I was like, maybe the 555 has something to do with it, maybe it's not getting a proper reset. And it made no difference. And then at that point, this is where I reevaluated things and thought, well, logically, there's nothing else it could be. There must be a difference between the chip that he's fitted and what was originally fitted. That, you know, it's Occam's razor again. You know, it's the logical explanation. There's no other rational explanation. Well, apart from a ghost. And that's not very rational. The point is, when you've gone through the motions and you think logically about the behaviour you're seeing, and the fact that everything's been swapped out and ruled out, it could only be that. There's nothing else it could have been. So I guess it was a natural conclusion. It's just, I'm surprised that I got there sooner rather than later, I think is the point. That's the sort of thing that, had I not known Anthony had swapped the chips out, I could have spent quite a while going around swapping chips and things and going, what is it? This, it's haunted, I don't get it. It makes no sense. Yeah, so there's nothing else really I would want to do to that if this was mine. Maybe resize some of the solder points there, but you know what, it's alright. So strangely, he had the washer on the underside there, which is, well, I don't know, that's a bit strange. That's the way it was. I'm not going to test his other IC here, you know, the other keyboard MCU. The chances are that it's alright. Let's just unplug this and strain this wire. Yeah, I made this in one of the A2000 videos. There'll be a link top right to that. And I made one for the 4000 as well, to go from this to an Amiga 4000, the mini DIN. There's not a lot of space on here, is there? This is the thing, it's all getting trapped. So let's try that, switch it on. So yeah, the LED came on. That's it. I'm calling it fixed. So I can put my MCU back in here. Intermittent. And I'm going to reinstall that resonator on my spare PCB here, which I don't know whether it works or not. Wrist strap back on. Yeah, it's chip here. So this is the other one, leg straightened up on that. I'm sticking that into this sponge ESD. So sponge, they came in this bag here. Yeah, don't ever send chips and things in bags like that if you can avoid it. So chances are these things are probably alright as well, that 555 and the 274 series. And I'll get a wee ESD bag to stick those in. Yeah, there we go, found an ESD bag that should fit that, I think. Yeah, I'll take that up and go back. Yeah, so if I had more time now, I would swap the chips over and test it, but until he can do that, I'm sure that chip will be alright. I don't think there's anything wrong with that. I think he's just gone through a couple of different spares here trying to work out the problem, that's all. I don't think either of those is the original chip. Could be wrong. Yeah, so testing all going well. No issues at all. I do like this keyboard, I have to admit. They just have a nice feel to the keys. The plastic feels better. And I assume these are the original keycaps. They might be modern ones, I don't know. They look absolutely pristine on this. But the press better, they're just more tactile. So yeah, and look at this Commodore symbol instead of the other Amiga symbol. Yeah, very cool. I like the way that LED looks there as well. And one final test here, just to make sure that the reset circuit works. If we leave the caps lock on and we do Control Amiga, you can see it go off there. Yeah, so we know we've reset the keyboard MCU. And obviously, if that was connected to a 500 now, it would send out the connection, you know, pull the reset line low, I think. But in this 2000 here, because I've not done the transistor mod to this 500 keyboard, it can't reset my 2000, is the point. But we can see the caps lock change there, so yeah, it's working solid. Very pleased. Yeah, coming back to scoping that crystal, we'll have a look. It's probably going to be the same as it was before. Yeah, look, 2.99. Oh, 3 roughly. It's like bobbing around 3, there's a little bit of jitter there. But the key here is, when I scoped this earlier, in retrospect, I think if I put times 10, mind you, I had times 10 impedance. Yeah, we're back to impedance again. Because I was scoping it, it was probably working. And if I'd been scoping it and testing the keyboard at the same time, it probably would have found that actually the caps lock worked and the keys would have worked, etc. And this is the thing, you know, if you scope things and you've not got a really high impedance on your probe, you can actually resolve the problem. And that would have been a clue. Had I noticed that, had I done that and noticed that at that time, then I would have been like, I think we need those 2 caps on there. Because, well, I wouldn't have said that straight away. I would have looked at it and gone, oh, it's not got any caps on the crystal. It really should have them. And then I may have looked at the other PCB, a later rev, and noticed that, yeah, the later versions did have the caps there. I still don't understand why we had to do this. It must have had a different chip on it at some point that, for whatever reason, didn't need those caps. So lots of testing on this. Let me just switch this off. It's working fine. I'm just going to pull one of the keycaps off. Let's go with the J. So let's just use the tool here. There we go. Yeah, these, hang on, that's come to pieces. This is the thing. They're known as the Space Invader keyboard, and it's because of the shape of this here. I don't think I've broken that, it's just come off. And they're also known as the Chicken Lips keyboard. And yeah, I am going to have to be careful how I reassemble this now. Because the chicken lips here, those are the chicken lips. And it's 2 contacts that go, they separate actually. They do separate. Right now they're joined. Oh, so much for trying to demonstrate this. Yeah, so I need to carefully extract this piece out of here now, the Space Invader bit, in order that I can carefully put this back and it's going to clip over into the key there, yeah, but I need to separate these two connections here. These are the chicken lips, and it's like two contacts that join together, yeah, as the key. In fact that's probably alright. I can just put that back on, because I think as I push that into position it's going to separate the two. But I need to be very careful with this, get it dead straight. Yeah, and I managed to get that back on. It was a case of getting it really straight in terms of the spring, and then just pushing it on, and it clipped on, and it works, as you can see there. So yeah, no harm done. That was a little bit stressful, if I'm honest. So that's where these keys get the names. For the Space Invader, you know, the underside looks like a Space Invader, the white bit, and actually the white bit usually stays on. You pull the keycap off, and the white bit's usually still there. So, I don't know, was that a bad removal? Is there a specific way to get these off? Honestly, don't know. But the quality of this keyboard is so much above and beyond the other keyboards. I'm so jealous of this. I really wish I could find one of these to purchase. So it was a haunted, and now it's not. We've blessed it and put holy water on it, IPA that is. And coming back to keycaps again, as you saw the recent C64 video where I did the clear keycaps and they all cracked on the bottom row, that guy really, really annoyed me actually with his, you know, oh well, everybody knows this, not to use IPA on plastics. That is absolute rubbish. Yeah, it's the fact that those keycaps are clear, they're transparent, they've got acrylic mixed with them. Acrylic, you stay away from acrylic. So you could argue that I should have known that, but I've never learned that in my 30 years of working on systems and things. And, you know, alright, I was only in the industry for about 5 years maybe back in the day, and I cleaned 1,000 upon 1,000 of keyboards with IPA. It was the go-to. If you look at lots of manufacturers in terms of what should I use for cleaning my keys and my screen on my laptop, IPA. That's what they suggest. Don't say, don't use IPA, it'll dissolve or crack key. No, it doesn't. It doesn't dissolve plastics. It doesn't affect plastics. There are some unusual types of plastics, but I haven't come across any on my channel up until those keycaps. So you could soak these keycaps here in IPA, will they crack? No, they won't. Yeah, same with any other Amiga or C64 key. Now, I think the only exception on the C64 keys is where you got the print on the front. I'm led to believe, and I haven't seen them myself, I'm led to believe stay away from the front of the keycap, you know, the side that faces this way on those C64 keys, because the you know, the prints can come off with a bit of IPA, but they don't crack. Yeah, it doesn't dissolve them. So anyway, so that did annoy me, that guy, to be honest. And I guess whilst we're here, the other thing that you can do when you're trying to diagnose something like this, one of these, is have a look at the keyboard clock and keyboard data signals. So clip the ground on there. Yeah, this adapter kind of makes it a bit easier to do. So it's these first two pins. This is going to be clock and data. I'll show you on the scope here. Yeah, so scoping the second pin there on that connector, you can see data when I press a key. Yeah, this is the data pin, I think, and then the first one is the clock. Yeah, and again that pulses, because I think it actually, when you press a key, you get the clock and the data generated at the same time, so it's not like you get a continuous clock on the clock pin. So I'm not sure which one of those is the clock and which one of those is the data, to be fair, but just looking at the schematics you could work that out. But anyway, at that time base on the scope there, we can see the same sort of thing. You get activity on both of them when you press the keys. Anyway, we're all done. So for the eagle eye, you can see I took the 555 out the socket. Oh no, I've had to put the socket back in the spares and put it back on the board. The reason being is obviously this is now going to go back to Anthony. It's going to go presumably into his 500, and the LEDs around here, this area needs to be pretty flat or these won't protrude enough through the case. So I figured the socket here would be a problem. And you know what, the socket Anthony fitted there, he may need to remove that yet. I don't know whether that's going to fit inside his system when he gets the lid on. So, well, he knows what he's doing. He just needs to make sure, you know, he fixes the two connections there when he removes the socket and fit these two caps across the clock connections there. The other thing I did with this is this point up here was broken already, the plastic thing, so I got a piece of flat metal. I used my PLCC extractor to actually, it's a solid piece of like stainless steel or something, and I sat this on it and I used the soldering iron. I just overlapped the two edges of the pieces that were broken and clipped it back on, so it actually hooks on here now. because that was, you know, damaged before it got to me. The side over here is okay, you know, the hook on each side, look. Yeah, so anyway, I'm ready to go back. Check out the links down below to Anthony's channel. Actually, he's got a channel called Floppy Dog, I think, which he only created, I don't know, 6 or 12 months ago. I haven't had a lot of chance to look at some of the videos on there, but the one or two videos I did have a quick look at when I had some time, he's done a really good job at floppy related issues on the Amiga, you know, fixing different types of drive faults and recovering data from disks and things, imaging disks. So do check out the link down below to the Floppy Dog. So I do hope you found that interesting. It was interesting for me to look at the Chicken Lips, Space Invader and this unusual problem. Anyway, if you'd like to support the channel, please see the Coffee and Patreon links down below. I will catch you in the next video.